In this first lesson of Chapter 1 of the course of plane geometry, definitions and basic elements of plane geometry are presented, such as points, lines, and planes, relation descriptions, basic definitions. This first slide shows how points, lines, and planes are referenced. The elements points, lines, and planes are the primitive elements of the flat geometry. To refer to the points, uppercase letters are used as A, B, K, P. To refer to the lines are used the lowercase letters like A, B, S, T, R, Z. We can also use the notation that refers to 2 points, A and B of the line, with a dash over the 2 letters, where A and B are 2 collinear points. The slide shows the representation using 2 uppercase letters with a dash over the letters A and B. To refer to the planes, you use the lowercase Greek letters alpha, beta, gamma, delta, epsilon, and so on. In this second slide, I present some conventional signals used to define the typical relations of mathematics. So you have that the epsilon sign represents the concept of belonging. We use, for example, the expression that an element belongs to the set M. The capital letter U represents the union of 2 sets, the union of 2 figures, and so on. The inverted U letter represents the intersection, which is the part that is common to 2 overlapping sets or 2 overlapping figures. The inverted capital letter C in the horizontal direction represents a set containing element or set of elements. The capital letter C represents the element or set of elements that is contained in a given set. This third slide in this first lesson describes some relationships between points, lines, and planes. These basic relationships are presented only by a description. Thus, the definition of collinear states that the points are collinear when these points are in the same straight line. The definition of coplanar states that lines or points are coplanar when these elements are in the same plane. The definition of distance states that this is a dimension between 2 points of a plane or a straight line, that the dimension between 2 collinear points. It can be represented by the letter D and the name of the 2 points in parentheses. It can also be presented as a line segment using 2 uppercase letters with a dash over the letters A and B. The definition of a half line states that it is a line that begins at a point on one side and is infinite on the other side. The beginning point could be the intersection of the line with a plane or the intersection of a line with another line. This slide continues to describe the relationships between points, lines, and planes. These basic relationships are presented only by a description. The definition of a segment of a line states that line segment is a part of a line between 2 points. It can be presented using 2 uppercase letters with a dash over the letters A and B. This means that it's a part of a line that is between 2 points A and B. When 2 line segments have the same length between the definition points, you can say that these segments are congruent. The definition of a half plane states that is the part of a plane that originates in a straight line or at intersection with another plane. That is, a line divides a plane into half planes. Each of the half planes begins at the line and continues to infinite. Each 2 half planes start in the line and continue to infinite. This slide shows the definition of a circle and circumference. The definition of a circumference states that it is a closed curved line with points are out at the same distance, called the radius, r, from a fixed point called the center. The definition of a circle states that it's a circumference without internal points filled, that is, the circle is a disk. It's called circumference to the curve, while the name circle is used for the curved field, this means a disk. The slide shows in figure 1.1 a circumference with a radius r between the center point C and the point R that belongs to the curve. Also presented is a segment of a line BC passing through center C that's called the diameter. The dimension of the diameter is equal to the dimension of 2 radii. The diameter of a circle divides the circle into 2 semicircles. The slide shows a circle in figure 1.2. This new slide shows the same basic elements: radius r, composed of segment of a line AC, the diameter composed of segment of a line BC, the relation between diameters and radius, that is, the dimension of the diameter is equal to the dimension of 2 radius. The diameter of a circle divides the circle in 2 semicircles, and the circumference in 2 semicircumferences. This last slide shows the definition of a circle, sectors, and segment. If you draw 2 straight line segments representing 2 radii, R1 and R2, the area within the 2 radii and the circumference of the section between the 2 radii marked in the drawing with the letter S is called the sector of a circle. In figure 1.3, the sector of circle marked with the capital letter S is the sector of circle. If 2 points are marked on the circumference E and F, and if the 2 points are joined by a straight line EF, the area between the straight line segment and the circumferential portion, namely the R, is called the segment of circle. The shaded area in figure 1.3 is the segment of circle.